Okay, so in this chapter, we are discussing about how to describe, explore, and compare the data. In previous section, we discussed about measures of centers, which is mean, median, mode, and mid-range. So here we are talking about the measures of variation, which means uh, if there is any kind of variation in the data from the center, we would like to find out. We would like to measure that variation, and we can do that by finding three different things: range, standard deviation, and variance. Okay, and our goal is not only to compute this measures of center and discuss about the variation, but also try to understand and what that data represents. And our focus is, instead of just computing the numbers, uh, we are planning to develop the ability to interpret the data and understand them. So when a rounding of measure of variation, whenever we try to measure round of the measure of variation, uh, so try to round it one more decimal places than in the data we have given. So that's the rounding of technique. How do we find the range? Range is actually, it's a difference between the maximum and minimum value. And since the maximum and minimum value could be outliers, the range is not resistant. It depends on the it affects by the outlier. Okay, so let's take one example. Let's say this is the example of the data, which is which is one of the example we discussed in previous section, which is a waiting time, which we discussed in previous section. So let's say this is the data, and we would like to find out the range. First of all, to find the range, we have to sort the data from lower to higher or higher to lower to find the maximum value. In this case, the maximum value is 75 and minimum is 20. So the range is difference between them, which is 55 minutes. And then there is one of the most important the variation we're going to discuss in this section, which is called standard deviation. How the data is deviated from its center is called standard deviation. So standard deviation measures measures the variation of the data. Okay, these are the symbol or notation we're going to use for sample standard deviation, which is small s, and this one is population standard deviation. So for finding the standard deviation, this is the formula for the sample, where x is the data, x bar is the mean of the data, and this sigma means summation, n is the number of data. And but most of the calculator we use, they use this formula instead of this one, but both of them are the same formula for finding the standard deviation. The standard deviation is measure of how much data values deviated away from the mean, and then value of standard deviation is never negative. You always get 0 or positive value. 0 standard deviation means all the data values are exactly the same value, and the larger the value of standard deviation means data are varied very largely. Okay, the variation is huge. As usual, the standard deviation can increase dramatically with one or more outliers, so it's no resistant. Okay, the sample standard deviation is a bias estimator of the population standard deviation, which means that value of the sample standard deviation as do not center around the value of population standard deviation. So let's try to find out the standard deviation for this data we have given. Data set of 1 2 3 4 5 6 7 8 9 10 11 data. First of all, we need to find out the mean, which is just sum and divide by number of data, which is 39.1 minute. And then after that, we have to our plan is to use this formula for finding the standard deviation. So we start with the mean. Always find out the mean. This is the mean. And then now we need to find out the difference between the data and then mean for each of these data. Okay, so these are the difference between this data and the mean. And then after that, for each of these data, we have to square them. So this is the square, and finally we need to add all this square, and this is the value, these are the square, and now you need to add them all, and sigma means it's the addition of all these difference, square of the difference, and this is the summation. And now we need to divide it by n minus 1. In this case n is 11, so n minus 1 is 10. So that's the value, and for finding the standard deviation we have to take the square root of this value, which is 16.556. We're going to round it to the 1 decimal place here because the data doesn't have, they are the whole number, so maximum we are going to round it to the 1 decimal place, so which is 16.6. This is the standard deviation for the sample. Okay, so by using another formula, which is very same formula but different ways of calculating it, we were discussing here. This is the formula, but you can also calculate the very same thing by using this form of the formula. They are the same formula. So in next example, we are using the different form of the formula. Eventually the value would be exactly the same. Okay, so range rule of thumb. The range rule of thumb is a crude but simple tool for understanding and interpreting standard deviation. The vast majority, such as 95% of the sample value, lie within 2 standard deviation of the mean. So after finding the standard deviation, we can say the vast majority of the data lie within 2 standard deviation. 95% of the data lie within 2 standard deviation. The meaning is, let's say here is the mean, and let's say S is that standard deviation for the sample, standard deviation for the sample, then 95% of the data will lie within this range from here to here. That's 95% of the data. Okay, so so here the chances of being in this range less than mu minus 2 sigma, which is standard deviation for the population. Mu is the standard deviation for the population. It's very significantly low, and then vast majority of the data falls from this point to this point, which is within 2 standard deviation of the the mean. And then anything higher than this value is significantly high values. Okay, so to roughly estimate, if you have to roughly estimate the standard deviation, this is just a rough estimation. Okay, we can find the standard deviation of sample by dividing range by 4. That's just a rough estimation. Okay, standard deviation of the population. This is the formula for standard deviation for the population. Remember, in case of sample, we try to divide by n minus 1. In case of the population, we have to divide by n for finding the standard deviation. That's crucial thing to remember while calculating the standard deviation. There is another measure of variance, a measure of the variance that's called variance itself. So that's the topic, measures of variation. And there is another way of calculating measure of variation by finding variance, which is actually after finding the standard deviation for the sample, if you square that will give you the variance for the sample, a square of the standard deviation. And then this one, which is the square of the standard deviation for the population, gives the variance. So this is another way of measuring the variation. So this is sample standard deviation, square of that is sample variance. This is population standard deviation, and this is a population variance. Okay, some of the properties we have to understand. The unit of the variance are square of the unit of the original data. So it's a square of the unit of the original data. The value of the variance can increasing dramatically within the inclusion of outliers. So a variance depends on effects by outliers. So its variance is not resistant. Okay. So now there is a reason for dividing by n minus 1 for calculating standard deviation for the sample, and while calculating the standard deviation for the population, we just have to divide by the whole size. Okay, so there is one finding I am going to share with you. About 68% of all values fall within 1 standard deviation of the mean, and 95% of the data falls within 2 standard deviation of the mean, and then about 99.7% of all values fall within 3 standard deviation rule of the mean. That's called empirical rules. Okay, so let's look at this picture here. As you can see here, this is mean, and about 68% of the data falls between 1 standard deviation, the range of 1 standard deviation. About 95% data falls between 2 standard deviation, and 99.7 of the data are within 3 standard deviation. Okay, so let's look at one example using this empirical rule. IQ score have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. What percentage of IQ scores are between 70 and 130? So as you go here to find out the percentage, you always have to subtract standard deviation from the mean. So here the mean is 100, standard deviation is 15. So 70 means it's a 200 minus 2 times standard deviation is 70, and 100 plus 2 times standard deviation is 130. So as we go here, mean minus 2 times standard deviation to the mean plus 2 times standard deviation represents 95% of the data. So in this case, it represents 95% of the data. Okay, let's look at some examples from this section. So the first one, a random sample of 10 subjects have weights with a standard deviation of 10.8659 kg. So this is the standard deviation. What is the variance of their weights? Be sure to include appropriate units with the result. Variance means it's a square of the standard deviation. So we need to find out what is the square of 10.8659. So we can use any calculator here. 10.8659 square of that is 118.067, and we need to round it to the 4 decimal places. So it's 118.0678. 118.0678, and then variance is the square of standard deviation. So the square of kg is kg square. Let's look at one other example, which is the listed below are the numbers. So here is the list we have given, a number of hurricanes that occur in each year in a certain region. The data are listed in order by year. Find the range, variance, standard deviation for the given sample data. So these are the measures of variation we need to find out. You can always start with here, just copy this data in Excel or StatCrunch. It's up to your choice, or you can use the graphing calculator, the calculator you have. I'm going to use Excel here, but you can use StatCrunch or some other tools as you like, as you wish. So these are the data. So first of all, to find the range is the difference between maximum to minimum value. So I'm going to sort this data by going here, data, and sort, and then if we just sort it from smallest to largest, now the data is sorting. So smallest one is 1, largest one is 20. So the range is, so we know the range means it's largest minus smallest, so which is 19 in this case. So range is 19. So it's in years. So the unit should be in years, 1 or more. What did I do wrong here? Years, the range of sample data. Okay, so number of hurricanes that occur in each years in certain region. The data are listed in order by years. This is the number of hurricanes, it's not years. These are the number of hurricanes, so it should be hurricanes. Okay, yes, it's the data represents the number of hurricanes, so unit should be hurricane. Now for finding the standard deviation, we can use the same Excel sheet here. Remember, the standard deviation, there is a formula we need to use for finding the standard deviation. These are the two formula. This is the formula for finding the standard deviation for the sample. And if you check here, it's a sample. So look at here, given sample data. This is the sample data. So we are going to use this formula. As you can see that you need to find out the average. You need to find the difference between the data and average, square it. You need to find the sum, and you need to divide that by n-1. So I'm going to do that here. So first of all, let's find out the mean. What is the mean here? Mean is actually sum of this data. I'm going to use Excel. You can do it manually, one by one, using the calculator, and divide by number of item, which is 14, as you can see here. So that's the mean. So now I need to, okay, let's do it. I'm going to copy this from second. So here it's x means the data, and okay, because my range depends on the data, so it's 20 minus this one, so it's 19 here. So the first column is data, the second column is x minus mean, which is, in this case, the mean is 7.357143. I'm going to use everything for the calculation without rounding it. Now for finding this, you just have to take this one minus this value, which is 7.357143. So it's a difference between the data and then mean value here. So if I just scroll it down here, it's going to calculate for me. Now if you look at the formula, we need to square this value. So the third column would be square of this value, x minus mean square. So I'm going to just use equal this data and square it. So if I just scroll down here, that's going to square for me. So now our goal is to find summation, meaning just add this everything here from this column. So I'm going to just find sum of this data, which is sum command I can use, or I can use manually by using other calculator. So that's the sum. This is this upper part. And now for finding the standard deviation, we need to divide this number by n-1. In this case, n is 14, so n-1 is 13. And eventually we need to find the square root of this number. Square root means power 0.5. So that is my standard deviation by using this formula. So I calculated this thing by using this Excel spreadsheet, but you can use StatCrunch, or you can also use calculator. It's up to you. Okay, so this is the standard deviation, which is 5.090931. But if we go here, we see that round to the one decimal place, so the answer would be 5.09, 5.09. And then the unit of standard deviation is the same as the data. Data is number of hurricanes, so it's hurricanes. Your second answer is correct, but your first answer is incorrect. Second answer is correct. So did I do something wrong? Okay, let me just go back here and check. So this is my, okay, check it here. What did I do wrong here? I found the mean, which is A1, not A1. Oh, okay, I changed this. When I copied it, I changed this value, so it's not from A1, it's from A2. Okay, so that's the mistake I did here, from A2 to A15. So when I copy and pasted, when I copied from upper cell and then pasted it down here. I did not change this value, so it's supposed to be 8.78. so that's the mistake I did. So we can always go back and correct our mistake, which is 8.785714. so this is 8.785714. okay, so now it's right. So I'm going to just do the same thing for each of this value. Now when I do that, my answer would change, and then answer would be 4.870296. if I have to round it to the one decimal place, it would be 4.9. so when I go back here and let's change it, 4 point, one more time, it's a 4.9. okay, so that's nice work. So remember, when playing with this Excel sheet or something else, we might, because we have to do this handle this huge data, sometimes we might make a mistake, so we have to be careful. We have to check our work step by step before we enter our answer. Okay, the variance means it's a square of this value, which is if you go back here, this one would be your variance, which is the square of the standard deviation. Okay, so that is 23.7 if you want to round it to the one decimal place, 23.7. and remember, variance is the unit of the variance is square of unit of a standard deviation, so which is square of hurricanes. Okay, so now finally we found the range, variance, and standard deviation. Now we need to answer this question: what important feature of the data is not revealed through the different measure of variation? Okay, let's read the given option here. The measure of variation do not reveal the difference between the largest number of hurricanes and the smallest number of hurricanes in the data. That's not true, because that is range. The measure of variation reveal nothing about how the number of hurricanes are spread. That is also not true, because that is what that's the whole point of finding this measure of variance. The measure of variation reveal nothing about the pattern over time. Okay, and then the last one is the measure of variation reveal no information about the scale of the data. So we can choose C, because as you can read here, all three other options, it's about the measure of variation. It tells you the variation, but the C option, the measure of variation, reveals nothing about the pattern over time. We cannot say anything over time by using this measure of variation here. Okay, that's number 5. Let's do one more problem. Let's say number 10 here. A group of adult males has foot lengths with a mean of 28.48 centimeter. That's the mean, and standard deviation is 1.43 centimeter. Use the range rule of thumb for identifying significant value to identify the limits separating values that are significantly low or significantly high. Is the adult male foot 25.2 centimeters significantly low? So we need to find out significant low value and high value. For that, we can go to this empirical rule. Where is that? Yes, this one. Where is significant low? And yeah, this one. So anything less than if it's if it's coming from population, then we use the mu, and if it's coming from sample, we use x bar. So that's it. The same thing is true for sample or the population. So it's a significantly low if the value is less than average minus 2 times the standard deviation. So here, as you can see, the average is 28.48 minus 2.2 times 1.43. So I'm going to use calculator here. 28.43 minus, I'm going to use parenthesis here, 2.1.43, which is 2 times standard deviation. Mean minus 2 times standard deviation. So anything less than 25.57, let me check, double check, it's a 28.43, that's a mean, and the standard deviation is 1.43. Significantly low values are anything which is a mean minus 2 times standard deviation, and according to this calculator it's a 25.57, and we are trying to write without rounding, so it should be 25.57. 25.57. Anything less than 25.57 has significant low values. So let's check the answer. What did I do wrong? Significantly low values are 25.57 centimeter or lower. So let me go back. I did something wrong here. 28.48. Okay, I did 28.43. It should be 28.48 minus, sorry about that, 28.48 minus parenthesis 2 times 1.43. Let me double check. 28.48 minus 2 times 1.43. Okay, so that's supposed to be 25.62, not 57. 62. Yes, it's right. Significantly high value, we are going to use the same calculator, but this time instead of minus it's supposed to be plus. As you can see here, for the significantly high value we need to calculate mean plus 2 times standard deviation. So mean is 28.48 plus 2 times standard deviation. In this case it's a 1.43. So anything greater than 31.34, it's a significantly high values. Okay, let's try to answer another part here. Select the correct choice below and fill in the answer boxes to complete your choice. Choice A, the adult male foot length 25.2 centimeter is not significant because it is between this and this. Okay, 25.2 is smaller than 25.62, so it should be B, because the adult male foot length 25.2 centimeter is significantly low because it is less than this value, which is mean minus 2 times standard deviation, 25.62. anything less than this value has a significantly low value. Okay, so that's how we can find measure of different measure of variation. We can find a standard deviation, range, and variance.